basically, it really kind of depends, and you'll see it in a lot of different locations, but ultimately what happens is the two meanders get too close to one another, and eventually it just keeps eroding and eroding. Eventually, the river breaks through that small piece of land connecting them.
How long did that happen?
A very long time.
The island?
Depending on, it's definitely longer than a human's lifetime, but not a million years.
So we can happen with
Maybe a couple hundred. Depending on the soil, depending on the speed, there's a lot of variability in there. I say we're definitely within a few hundred years, 200 years. And then, next question, okay, so fine, that happens. What happens next? And then we start getting these things called oxbow lakes. If you look at letter C is an oxbow lake. We see the same thing right here.
Is it going to eventually run away?
In fact, I would almost dare say I think this is that the same image that's on your map?
Yeah.
Is it really?
Uh-huh.
I really did not mean for that to happen. That's pretty cool. Alright, so what I want you to look at here, take a look at this image out here in the lower left. What's happening in this region? What happened there? Okay, Sean, what did you say? They got closed off. And that'll happen with a lot of oxbow lakes. Eventually the oxbow gets closed off. And then what starts filling in? Yeah, you get the swamps. You get what we call eutrophication. And that's a big term. Eutrophication. Okay, so eutrophication, eutrophication. And all that means is the process of going from water, you basically have plants that start taking over. Okay, so you have excess nutrients that are deposited, allows for plant growth. Some of you guys might live on small lakes or ponds, and you have noticed that your pond starts to get shallow. Are you starting to get a lot of plant life that's growing at the bottom of your pond? That is a natural process. When we look at swamps, a lot of your swamps, over time, will just become low depressions filled with trees. And that's all because of eutrophication. So over time, this little dip in the river channel actually starts filling with vegetation. And in fact, eventually the entire oxbow lake fills in with vegetation, and then all you have are these horseshoe-shaped depressions. If you ever look at a map of the Mississippi River, it is littered with thousands of oxbow lakes. All you do is get out any atlas and just follow the length of the river, and you'll see oxbow after oxbow. And it's where some of your major rivers basically have created these oxbow lakes. Okay, so we've kind of already shown you guys this concept right here. We're talking about the can't think right now. Where the sandbars, but again, we're wider on the outside, thinner on the inside, and that's pretty much all I have for you guys here. The last thing I want to talk about, you guys, about here, remember we talked about rivers change very rapidly. They're not constant at all. This is actually really kind of interesting to see how much the river changes and how quickly oxbow lakes get cut off. So, Brandon, this might actually answer your question. The green channels from 1935. That was the original river flowing in this direction from left or from right to left. Okay. Within 23 years. That's how much it changes. So now start looking at what has really changed in this. And one of the spots really starts to pop out. You see how we cut across 1 and 2? So we actually cut off this little loop right here. So we actually, within a matter of 23 years, we created an oxbow lake. And then to go from 1935, or 1958 rather, 1973, the river really doesn't change much. But one thing you should notice is what happens in this region. Yeah, that meander is really starting to get stretched out. Okay, so what do you think is going to happen in the near future? Yeah, I can see it's definitely cutting both of those off. So let's find out. So from 1973 to 1990, oops. What do we do? We actually cut off both of those meanders. So, in a matter of just 55 years, this is how we changed from the original to the final. Now, I'm not saying we have these widespread changes, but you can definitely have small changes easily within 50 years. So that's just something I thought you guys would like to see, kind of to see how much river really does change. So that's really all I have for our notes today. But I want to make sure you guys understand again how oxbow lakes are formed and how point bar depositions are formed. Those are your two big ideas for today. And you will need to be able to explain to me how both of those work for the test.
Can you go over the point back there?
Point bar, one more time.
Like, because, like, just carrying.
It's all about carrying capacity.
Outside.
Yep. So again, one more time on the point bar deposition, because this is so important that you guys understand this for the test. Big, major concept of the entire unit. As you go around the meander, the inside slows down, the outside has to increase its velocity. As you increase velocity, you increase carrying capacity. So therefore, the outside of the river is able to erode more, so it erodes the outside bank because it has a higher velocity. On the inside, it slows down. As velocity decreases, you lower your carrying capacity. So therefore, those sediments that were held in suspension can no longer be kept in suspension, and therefore they fall out and become deposited on the inside of the meander. Okay? All right. One last thing. Big, major concept for the class. Not just for this unit, but for the entire course. Everything in nature is trying to reach what term? Starts with an E. Equilibrium. Everything in nature is trying to reach equilibrium. It's trying to become balanced, correct?
I like 106.
Yes. Okay. Now, how does this apply to streams? Each stream has its maximum carrying capacity. That's when it's reached equilibrium, is when it has maximized its carrying capacity. So that's why if you increase the carrying capacity on the outside, that part of the river gets really hungry. And in a desperate attempt to reach its equilibrium, it starts eroding all the material that it can to reach its carrying capacity. The inside helps it do that because it loses its carrying capacity. Now, remember I told you guys about river channels, putting them into a narrow channel in the city? And then yes, it helps out the city, helps control its flooding, helps it with city planning that you have a straight edge versus this winding river through downtown. The problem is when that river leaves the city. Because as you put that river in a narrow channel and it's flying through the city, what happens as soon as it leaves the city? Yeah, it's actually still moving relatively fast. So it starts eroding away at the banks on the outside of the city. And so a lot of our farmland is eroded because of the narrow channels that are put in place in the cities. So that's just something to keep in mind there when you guys start looking at things and understanding how our decisions affect the world around us. All right, so that's all I have for you guys today, and then we'll have homework, and that's pretty much it.